morning. Welcome to IIT Madras, and I want to thank all of you for choosing to come to IIT Madras in Chennai, and I want to thank the organizers for giving me an opportunity to speak here. So, some 2-3 decades back, telecom also used to be one of those things where we used to wonder how do we overcome the shortage, how do we make sure everybody, that telecom reaches a large number of people. Telecom services are available only to a very small number of people. Even now, there are of course problems in some areas, in some rural areas, and some segments of the population. Affordability is an issue, but it is getting rapidly sorted out. So I'm not going to focus so much on making sure telecom services are available to everybody. I'm going to focus more on what can telecommunications do for the country by 2047, because it has done wonders in recent decades. So how can one forecast so that one can make plans in addressing other challenges by leveraging what telecom can do for us? So we want to forecast what telecom might be like 25 years from now. So let us see how we might have forecast what telecom would be like today in 1995, roughly when many of you would have either been just born or 2-3 years old. So a lot of the India I'm going to tell you about in 1995 or before that you may not even be aware of. It cost, I'm writing in dollars mainly because it's a simple way to first order of getting inflation out of the picture. I mean, dollar also has inflation, but much less. So if we talk in dollars, you sort of get rid of this problem of 8%, 9%, 10% inflation that we had for many years for the rupee. So you don't have to worry about constant prices and all that. So it cost $1,000 in 1995, even more actually, to install a landline, which was a almost the only way of providing telecom services, just for voice calling and maybe some data through modems. And this needed a revenue of at least 750 rupees a month at those prices. This one I did not bring it to today's prices to even make this viable, this investment viable. And this kind of revenue per line, very few people could afford. Even people who are employed in jobs like mine could not afford it. And therefore, there were less than, sorry for the typo, there were less than 10 million residential lines in 1995. And out of that also, more than half would have been provided by the employer. Mobile phone technology was just beginning to boom in the West. GSM sort of came into its own in the late 80s and early 90s abroad. Feature phones, there were no other phones. Feature phones cost about $150 or more. I think so. I'm trying to remember that is the number. I don't remember it clearly, but I think it was around that much. Good phones. Talk time, in fact, you had to pay rupees 8 or 16 per minute, and you actually had to pay for incoming calls also. Okay, and mobile phones were used therefore only by the rich, and and also for business, salespeople, etc. It made a big difference. So people like us, many of us never had mobile phones, right? It was too expensive. Could anyone have forecast that 10 years from then, 2005, that feature phones will cost only $25? Okay, and India was one of the places where this boom really occurred. Talk time cost will drop to sub-rupee levels per minute, and incoming calls will become free. And that another 10 years after that, or 25 years there, let's say by just 2020, that voice calls will actually be free countrywide. This notion of STD and all just went away, right? And 600 million Indians will use wireless broadband via smartphones. That's roughly the number of registered broadband subscribers today. 160 million smartphones costing an average of about 14,000 are sold. Actually, they're now also made in India, at least assembled in India, and sold per year. Now, this is a very accurate number, by the way, because every phone has an ID, so we actually know which models and how much people are paying for them. This is one of the most accurate data sources that you can get today, and this actually I've been telling people to use this as a good proxy for in economics for other assessment. 14,000 rupees per year is the average cost of a smartphone that was bought last year, and 160 million. Assume that smartphones last 3 years. There are 500 million smartphones in use today, right? In 250 million families. So obviously some families have 3 or 4 and some families have none. But you can see this is not one of those things that has not penetrated deep. A lot of families have smartphones. Okay, and 75% of the private final consumption expenditure. I hope all of you have been taught what that is, but that is roughly the expenditure that occurs at the household, final level, that means whatever you and I buy, right? Which is roughly in India about 100 lakh, 133 lakh crore last year. 100 lakh crore is happening via UPI now, about 8 point something lakh crore per month, right? And all that is happening through the smartphone. So this is remarkable, absolutely remarkable what has happened. So, and absolutely, I'm telling you, nobody had a clue at any time, at various times in these 25 years, nobody had a clue any of this is going to happen. So that tells you that we're not going to be very good at forecasting what 2047 is going to be like in telecom. Let's accept that. And why did this happen? I think it's very important for us to understand a little bit of what made all this happen. Why was it not forecast? Well, you know, for the feature phone, for the smartphone to become so inexpensive and so powerful, one of the technologies that had to happen was that radio frequency circuitry that works with signals that are at 2 gigahertz, 3 gigahertz, and so on. This had to go into the same low-cost semiconductor technology that was already there for computing. Now, this was not an obvious thing, at least in the 90s, early 90s. Some of us didn't see it happening. Okay. In the earliest feature phones that I talked about, the radio circuits were still in separate ICs, and it was not clear they could ever go into the same IC. So there were developments that occurred in semiconductor technology, in microelectronics, that made this happen. Moore's law was, I think, probably the only thing that was very clear by 1995. Yes, digital chips, ICs that do digital circuitry will keep becoming denser and denser. Every 18 months they will double in density. That was clear, but that everybody thought will affect only computing. It can't really have that much of an impact in telecom because the first point was not clear. The next thing that was not at all there was display technology. Even as late as 2007, I saw that I gave a talk somewhere where I said, where by then this, the rest of it had happened and we could see wireless providing broadband. You don't have to lay wires, and that was a big challenge in this country. So I remember giving a talk saying that, I think the connectivity problem is solved, but where are the devices? You still need a laptop, it's unaffordable, you still need, even tablets hadn't really come. So device was seen as the biggest challenge. And yet, display technology, what you're all using in your smartphones today, this LED and OLED displays, this really also nobody saw it coming. In fact, one of the major developers of this technology is Kodak. I don't know, I hope you all know what Kodak is. If you still used photo prints, Kodak was the world leader in the paper that was used for printing photographs. And Kodak developed this technology initially for displays, and they actually literally licensed it away to the Koreans and saying, who wants this? Okay? And of course they ate their lunch because there's no printing of paper anymore. There's no photographs anymore. So actually Kodak should have moved from storing photographs in paper to storing photographs in phones, but they didn't. Okay, so even they could not forecast. A whole global company went kaput because they could not forecast. Okay, and this is very important because, even today, you will not work with a keyboard on your laptop, on your computer, which is not, keyboards haven't changed much in 30 years. People still feel that unless it's that size and the way it is and so on, it's not good. But it's amazing how people are willing to work on small phones and how they use their thumbs. See, we can't forecast these things, where human beings will find a comfortable, that is good, where they will discard it as not being user-friendly. It's very, very difficult. Okay? So this was another thing. And of course, GPS geolocation. So military technology now used to track each one of us. So if you go on the road in a car, it tells you, it knows that you are a vegetarian, it tells you there's a good vegetarian restaurant on your side of the road. Okay, so it knows where you're going. Sensors like accelerometers. If you turn your phone, your screen turns. How does it happen? There's an accelerometer inside. Where did that come from? It was developed for airbags because there was a big problem with road accidents in the US, and there was a big push to make sure that people don't die in car crashes. So this accelerometer, low-cost accelerometer, was developed which can trigger the airbag as soon as a collision happens. Huge change in acceleration. This same device, it costs so little cents that they just put it in the phone, and now it's being used for all these things. So all these things were not forecastable at all, the cameras that you are using. Above all, and very important, I don't know, this actually slide itself can be a full talk. There's a new business model that was created. Now, whether they did it knowingly or unknowingly, when 2G came, the phone it was decided that the air interface, the interface between the phone and the tower, would be standardized through global standards, so that different people can make the phones and the other stuff, the rest of the network. And the phones were spun off as a consumer product. This is a big business policy decision. Before that, telecom, right up to your instrument in your home, is all supplied by the service provider. He will come and install the phone in your house. In fact, BSNL used to send somebody to clean your phone every 3 months. Okay, so the model was completely changed, and that has very interesting consequences. And from a governance point of view, all of this actually was what made this happen. Today, what you're seeing, the miracle of what people are able to do. They are able to deposit money in the people's accounts. As somebody was just talking about that when they walked in. All of this became possible because of this. Now, can we dare to look into the crystal ball? For sure, there is going to be what's being now labeled as holographic type communication. It doesn't mean it's holograms, just means that you'll have much more realistic telepresence in video conferencing. Okay, broadly. It requires a lot of bandwidth. There will be something called tactile internet-based remote operation. You should be able to operate machines and even do things like surgery remotely, right? Without feeling that you are not present at that point. Will there be tactile sensors for feeling textures like cloth? Will you be able to shake hands? Don't know. Not sure at all. Most likely there will be quantum computing, communication security, unimaginable search space because of the quantum computing, highly secure transactions. This is most likely to happen. Second one, all depends on what new materials, new sensors are developed. Who will call the shots? This is very important also. It's my last slide. There have been tectonic shifts in who holds the aces. Initially, it was telecom giants. You probably don't know these companies anymore. AT&T, Alcatel, Siemens. Alcatel and Siemens are now doing other things. They're not doing telecom. Mobile phone giants. Some of them still exist. Of course, because they are still there. Ericsson, Nokia, Huawei, Samsung, Qualcomm, and so on. They made what you are seeing today and what made the revolution. Right? These are some of the questions that we have to ask ourselves. And forecasting is really not possible. You have to be ready to keep observing what's going on in a 5-year horizon and keep reinventing your other policies and the way you address other challenges by leveraging telecom. You have to keep modifying that, because I wouldn't dare to forecast what it will be like 10 years from now or 15 years from now. Forget about 25. Thank you.